Okay, let's apply the quotient rule of exponents to divide monomial expressions. So if we look here, let's start with our basic algebra expression, x to the ninth divided by x. If we want to think about this, what does x to the ninth mean? It means up in the numerator, I would have 9 x's connected by multiplication. Well, do you really want to write out x times x times x times x, blah, 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 blah? No. So the rule here is when we divide, as long as our bases are the same, all we need to do is subtract our exponents. So let's look. What is our base? It's x, because the base is always connected to the exponent. In this expression in the denominator, what is our base? Our base is also x, so we have the same base. When we divide, we do nothing with the base. The base stays the same. The base is still going to be x, just like when we multiply. What we're going to do is subtract our exponents. Now we got to recall, every variable has an exponent. If it's not written, what is it understood to be? That's right, it's a 1. So this is 9 minus 1, which is 8. So x to the ninth divided by x to the first would be x to the 8th. Simple as that. Let's go to our next monomial expression. 20b to the 12th divided by negative 4b to the 11th. Remember, these are monomials, so they're connected by multiplication. So because we're connected by multiplication, we can divide. So again, we've already talked about this when we were doing multiplying monomials. When we divide, we do the coefficient with the coefficient, and then we do the variable with the variable, just like when we multiply. So the first thing we're going to do is do 20 divided by negative 4. Well, a positive divided by a negative is a negative, and 20 divided by negative 4 would be negative 5. Okay, now we're going to divide the variables. Again, we can talk about what b to the 12th means. B to the 12th means there are 12 b's in the numerator connected by multiplication. Do you guys really want to write that out? I don't think so. So we've got to learn our rules. The rule is if we divide the same base, we can subtract the exponents. The base here is b. The base here is b. So when we divide the same base, we subtract the exponents. 12 take away 11 would be 1. This would be b to the first. Now, do we write our answer when we divide? Do we need to write the exponent of 1? No, we do not. So in an algebra book, this answer would just be written as negative 5b. All right, let's try one more. Our last division of monomials. Remember, it's a monomial because it's connected by multiplication. It's a monomial because it's connected by multiplication. So we're going to divide. Negative 63 divided by negative 9. Do the coefficients first. Well, a negative divided by a negative is a positive, and 63 divided by 9 is 7. Now we're going to find the same base. Now, understand my vocabulary. I'm not saying find like terms. Now, remember, to be alike, the letter would have to be identical with the same exponent. So these are not like terms. We're just looking for the same base. If this base is x, I can only divide it with another base of x. Okay, so this is what I'm going to divide. I'm going to divide x to the 7th divided by x to the 1st. And if I take 7 and 1 and subtract it, I would get x to the 6th. Think about it. There's 7 x's up here, and there's only 1 x down here in the denominator. Well, one set would cancel out, and you'd be left with 6. Do I have any other bases that are the same? Yes, I have the y's. I have y to the 10th and y to the 6th. They're the same base. So I'm going to divide them, which means I'm going to subtract their exponents. The base stays y, but there's 10 y's in the numerator. There are 6 y's in the denominator. So if I take 6 from 10, I'm still going to be left with y to the 4th, 4 y's. So the quotient would be 7x to the 6th, y to the 4th. Just think, division is the opposite of multiplication. If multiplication means to make bigger and we add exponents, division means to make smaller, which we subtract exponents. Okay, we have a lot more to learn. See you in the next video.